Hello friends, this video on alcohol, phenol and ether part 10 is brought to you by examfear.com. No more fear from exam. Now we will study about the preparation of alcohol. So we'll study the preparation of alcohol from alkenes. In that case, we'll study the acid catalyzed hydration and hydroboration oxidation. We'll also study the preparation of alcohol from haloalkanes by hydrolysis. From carbonyl compounds also we'll try to prepare alcohols from aldehyde, ketone, carboxylic acid, esters, anhydride, esters. So from all these also we'll try to prepare alcohol. We'll also try to prepare alcohol using granulate reagent, triamine and fermentation of carbohydrate. This is what used generally in industry. So we'll talk about all these methods of preparation of alcohol. Now we'll study preparation of preparation of alcohol from alkenes using acid catalyzed hydration. See, the reaction is pretty simple. I have alkene here, right? So now when I add water to this, the double bond break, and one place I get hydrogen, the other place I got OH. That is the reaction. The mechanism, if you want to see this is my double bond. Now it can break in any fashion, right? So it will get a negative charge, it will get a positive charge. Now H plus will attack, that is the acid. H plus will attack and the bond will break. Correct? This is how it will happen. Now what you get is carbon with the positive charge and CH. If you see, the carbocation is formed and this is a nucleophile attack. Correct? Why nucleophile? Because this, after this plus is formed, water attacks, right, and attacks this position. So what you get is I have water here. So water will attack this. This is a nucleophile attack. Now with this, what you get is COH with one lone pair here. Here it was two lone pair, and one lone pair is used to form the bond here, and carbon will get oxygen will get a positive charge. Correct? And now we have this plus charge in oxygen that is unstable. To get rid of this plus charge, this hydrogen bond will come out. So what you get is something like this. Yeah, something like this. This is a typical reaction mechanism for this. And it follows the Markovnikov rule. Why? Because we have the carbocation formation here, and this is suitable only for secondary and tertiary alcohol. So for primary alcohol, we have to use diborane followed by oxidation. We'll discuss about this in the next slide. Just understand this. In this case, the reaction mechanism. It is acid catalyzed hydration. That means you need H plus and water. The bond breaks. You can break in any fashion to make sure you get stable carbocation. For example, if I have something like this and you are having this acid catalyzed hydration, we have two ways to break the bond, right? This carbon this is 1, this is 2, this is 3. C1 C2 bond, you have two ways to break. One is this way. So in this case you get something like this minus, and this is a positive charge, and the other way is this way. So in this case you get here negative charge and here positive charge. Let's suppose you add H plus, so H plus is added here. Here also you add H plus, added here. So now if you see, in this case you get 2 degree carbocation. In this case you get 1 degree carbocation. This is more stable, right? So this will not happen. This will happen. Correct? Because the formation of 2 degree carbocation is more stable, so it will take this route, and now this will be the product. So in this case, now on H plus you will get OH minus here, you get something like this. This is the product you will get for this reaction. Correct. So how you understand? You have this carbocation formation. You will try to form stable carbocation. That is, you will follow Markovnikov rule. Correct. So one with the lesser number of hydrogens, the carbon with the lesser number of hydrogen, in that carbon OH will be attached. So let's see the reaction mechanism of this hydroboration oxidation reaction. I have CH3, CH, double bond CH2, and then I have BH3. This boron is very much electron deficient. We know that, right? So this electron will be attracted towards this boron. Since the boron can have only 3, it can't have 4 bonds, this hydrogen will go off. Right? When it will go off, this hydrogen bond, it will go off here in this bond. Actually, so what you get is CH3, CH, one hydrogen bond here, CH2, sorry, it was CH2 here, and then you will get BH3 here, BH2 here, sorry. Yeah. This is what you get. Why? Because the vacant 2p orbital of boron, so boron is electron hungry. Now I have H2O2 and NOH. As I told, right, this is for oxidation, Na plus OH minus. So what it will give is HOO minus and water. Correct. NaOH you can write as OH minus. You get this output. Now let's see this beautiful reaction here. I have Br3 trialkyl boron, and this is electron deficient. Boron is electron deficient, is electron hungry, and this has a negative charge, so this will be attracted. Electrons will be attracted towards boron because boron is electron hungry. So what you get is something like this. And now since it has lone pairs, right, lone pairs will move in this direction, right? So negative charge will come to boron and positive charge will come to oxygen. So positive and negative will be neutralized to the oxygen, but negative charge you will have in boron. Correct? It has negative charge. The electron move from oxygen to boron. Boron will get negative charge, oxygen will get positive charge. Positive and negative charge in oxygen will neutralize, and it will get no charge in oxygen. This is what it will be now. It also will have lone pairs. Now what will happen is, if my OH leaves now, this will get a positive charge. Correct? And that will not be good. There will be some rearrangement happen here. So this R will go to this oxygen and this bond will break. So there will be rearrangement happen, and what you get is BO. After that you get R here, and you get R, and the OH minus is gone. The whole system had negative charge, which was making it unstable. So now this negative charge is gone. The same reaction will happen again and again. Right? You do it H2O2 plus NaOH twice. So what happened here, if you see, it was B3R, now it is B2R and 1OR. So next time this R will be replaced with OR, and this time this R will be replaced with OR. So twice I am doing is, so what you get is B and 3 times OR. Trialkyl borate. Now if you have this and you add NaOH to it, 3 NaOH, because we have 3 here, you get 3 ROH and Na3BO3. This is my reaction. So if you see here, you get primary alcohol. So this is my typical hydroboration oxidation reaction. So this is preparation from haloalkenes. Haloalkenes we know is alkane is nothing but RX form. X can be fluorine, chlorine, bromine, anything. And we have seen this kind of reaction, hydrolysis. So we have something RX and we hydrolyze this with dilute aqueous KOH and you get ROH. So and KX. So here OH minus is a very strong nucleophile. So this OH minus is a strong nucleophile. strong nucleophile. So here it will have SN1 or SN2 reaction depending on it is 1 degree, 2 degree or 3 degree. We have discussed these things in the earlier chapters. So it will be a substitution nucleophilic reaction, maybe SN1 or SN2, we don't know, depending on the degree of this R, correct? And if you talk about the reactivity of haloalkanes, we know that Ri is more reactive than RBr, than RCl, because this is better leaving group, right? So that way this is more reactive. This is something which you already know. And OH- is a very strong nucleophile. So if you see the reaction mechanism, I have something RC, let's suppose this is my compound, right? OH- will come here, a very strong nucleophile, it will attack this carbon here, and it will kick this chlorine out. So you get RCHHOH, correct? And we'll get this alcohol pretty easily. Why? Because dilute aqueous KOH, OH- is a very, very strong nucleophile. The next is aldehyde reduction. So let's see this aldehyde. When you reduce aldehyde, it gives primary alcohol. So I have RCOH. Sorry, aldehyde, not acid, RCOH, yeah. This is my aldehyde, and I do a reduction using hydrogen, I get RCH2OH. And the reducing agents are generally LiAlH4, you must have seen this compound, NaBH4. These are my reducing agents. And this is nothing but my nucleophilic addition reaction. If you want to see the reaction mechanism, I can show it. So let's suppose I take this guy, CH3COH, this is my aldehyde, and I have LiAlH4. So if we see LiAlH4, it is something like this. I have H, I have Al, H3Li, where H gets almost negative charge here, and this side has positive charge. So if you see here, the electrons move because oxygen is more electronegative. It gets slightly negative charge, gets slightly positive charge. It has positive charge, the H, the nucleophile H will attack here. Please note here you have nucleophile H will attack here, and since it gets negative charge, this whole compound will attack this side. So what you get here is CH3CO, this whole thing here, that is AlH3Li, and here you get H. Now what you can do is you can add H plus here, you can do a protonation, and this is a good leaving group and it will go off. Since H plus, it will attack this lone pair here, right? And this will come out actually. Actually, this will attack H plus. That is how the reaction is, right? You show it in this fashion. The electron movement from here to here, correct? It has lone pair of electrons. The electrons move from O to H. So show in this direction. So it will become CH3, COH, HN, H. Correct? Always show in the direction of movement of electrons. So electron move from, there's a lone pair of electron moves from here to H. So you get, negative charge should come on H, but negative and positive, because of positive it has already had, it is neutralized, and this is there. Correct? And this goes out with a positive charge. Plus I'll say AlH3Li. Actually, this also breaks. This one breaks. Now I'll see ketone reduction. So this is similar to my aldehyde reduction, exactly same, but the only thing is there we're getting only primary alcohol. Here we can get secondary alcohol. So here you get 2 degree alcohol. So if you see, it is something like this, R dash, right? So if I had H here, you get OH and H here. Correct. Same thing here will give LiAlH4 or NaBH4. Nucleophilic addition. So the reaction mechanism, if you see, it is something like this. Since oxygen is more electronegative, it will try to attract electron toward itself. Slightly negative charge, slightly positive charge. I have LiAlH4. It is something like AlH3. Right, this is what? This is a negative charge, this has positive charge. So this negative charge will be coming here and this whole positive will come here. So what you get here is H here with LiH3, the lone pair. Here you can do a protonation. This will attack here. So oxygen will get 3 bonds. It will try to get rid of the positive charge. The electrons will move from here to here. It will come out. So what you get is OH here, H here, R here, R dash here, and AlLiH3 plus. This will go out. This is what you will get. Correct? Nucleophilic addition reaction. The next is from carboxylic reduction. It will follow exactly same mechanism we have seen. So here if you see, I have my RCOH, right? Same thing, I'll use H here. Instead of H, I use actually LiAlH4 or NaBH4. I get RCH2OH. Same reaction is a nucleophilic addition reaction here. So here also if you see, it will go in this direction, slightly negative charge, slightly positive charge. I have LiAlH4. Right, this hydrogen will attack here, this nucleophile, and this whole thing will attack this guy. So what you get here is LiAlH3, and here you get H, and here you get OH. Correct. So with this, again you do a protonation on this. So this has lone pair, it will attack this, and this will go off. So what you get this is OH, and H. Now if you see in one carbon there are 2 OH molecules, we have seen that's too heavy for it to maintain, so it will lose water. So it will form RCOH. Now you see this is what is my aldehyde, and from this again same reaction will happen. We have seen from how you get alcohol from aldehyde, same thing. The slightly negative, it will get negative charge, slightly positive charge. Again I have LiAlH4, right? This negative will attack here and this whole positive will attack here. So what you get here is RCO, LiAlH3, and here you get H, here H. Again you do a protonation on this, it had lone pair, it will attack this, and this bond will break. So what you get is R, COH, H, and H. And this is what I was looking for. Correct? See, same thing from carboxylic acid. First you get actually aldehyde, and then the same reaction proceed. Correct? And then we have acid chloride reduction. So here we will use RCOCl. This is acid chloride. Here also you use in presence of PD catalyst, I use H, add H here, now you get RCH2OH plus HCl. Same nucleophilic addition reaction, same reaction mechanism. Same thing I have for this guy, anhydride reduction. So anhydride is something like this. Now in this, again I'll use the same thing, LiAlH4. So here I'll get RCH2OH and RCOH. This is also my nucleophilic addition reaction. So let's see the reaction mechanism here. So this is a slightly negative charge, slightly positive, and I'll attack this guy with same LiAlH4, H minus, and LiAlH3 plus. H minus will attack here and this will attack here. Correct? Actually, it is other way around. It is attacked from here to here because the electron actually flows from oxygen to this compound, right? So you should draw in this direction. Yeah, this is fine, right? This is one circle. Now with this, what you get is RCO LiAlH3. You get H here, OCOR. Now if you see what happens, this is a very complex intermediate. It will collapse. So what will happen is, if you see here, this bond will break, it will form double bond, and this guy will go out. Since going out, it will get a negative charge. So what you get here is RCOOH plus, let's suppose it is R dash here, R1 COO O minus. Correct. So if you see here, what is happening is, on this I'll do a protonation, so H plus will come here, right? So you get this compound you got already. Now for this, again I'll do the same thing, LiAlH4. Correct. So if I do this again, same thing, negative, same thing, positive. So what you get, we have seen this reaction, actually we get RCH2OH, right? From aldehyde to alcohol. We have seen this, not a difficult one. Correct. So the next is ester reduction. So we are reducing ester here. So RCOO R dash. Again, to reduce, we'll use the same element, LiAlH4. What you get is RCH2OH plus R dash OH. Same thing, nucleophilic addition reaction. If you want, we can see the reaction mechanism here. So we'll use H minus Al LiH3 plus. So this will go in this direction. This will be negative charge. This will be positive charge. This H minus will go here, and this O minus will attack this guy. Correct. So what you get is RCO, this Al LiH3, and here you get H, and here OR dash. But it's very complex. Again, it will collapse. So what will happen is, this bond will break. Correct. This bond will come here, and this guy will leave. So what will happen here is, you get RC, it will be double bond O, and it will H, and here R dash O minus will leave. In this again you can do a protonation of this to get R dash OH. So this is formed, and this you can again add this. Again, on further reduction you will get RCH2OH. This we have seen, right? This is aldehyde. On reduction we will get RCH2OH. Very simple reaction mechanism. Hope you'll remember this. See, in most of the case, LiAl4, this is how it reacts. You get H minus and this whole thing as a plus. The next is the hydrolysis of esters. Pretty easy reaction. Here you use dilute acid, or alkali also is fine. For example, if this reaction is RCOR dash, you react with NaOH, aqueous. What you get is this Na, there's a lone pair of electrons here, is Na plus OH minus, there's attack here, it will come out, you get RCOONA, and you get R dash OH. Pretty easy, straightforward reaction. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.